Hello Year 12. I hope this video finds you well. I thought I would do a video on double titrations after work I set to today. I've got my helpers as well. My daughter, wait a second. It's okay, you haven't got to be on it. My daughter is the camera girl. Hello Ava. And this is my son. He's going to be in our videos because I find it very awkward talking on my own. So this is Emmett.
Yeah,
say hello, Em.
Yeah, yo.
Right, come on, be sensible now.
Okay.
So,
hi.
This is today's little video. It's only going to take a couple of minutes and it's called double titrations. Okay. Right.
Go right.
So you get in the right place, Saves. Double titrations. Now I've mentioned this to you before in class. But what it is, when you have a...
You might not be a school mind.
Pardon?
Might not people be from your school watching it.
Oh, don't worry about that. I might. And basically what it is, it's a titration which involves a mixture of two alkalis. Sodium hydroxide and alkali/bases and sodium carbonate.
Wait, why has it got
No.
NaDN?
Right, what's that, babe?
Why has it got NaDN?
That's NaOH. That's my O. Okay, so what we need to do, we need to find out the concentration of both of these substances. And the way we do that is that we use two different indicators. Two indicators. And the indicators are phenolphthalein. I'm not going to try and spell it because you'll make fun. And also methyl orange. Now, when you do this titration, I posted a video of another school that has done this experiment so you can see it. When you do this, there are basically two steps. Now, the first colour change will be the phenolphthalein, and it goes from pink to colourless. Okay? And this does not give us the amount of moles of one substance. It actually gives us the amount of moles of both the NaOH and the sodium carbonate. As the sodium carbonate doesn't fully neutralize, it actually changes into sodium hydrogen carbonate. Now that's why we need to test for the second titration where we use the methyl orange. And methyl orange goes from kind of a yellow to, I would say, an iron brew colour. Iron brew colour. I don't know if you guys know what iron brew is. It's like an orange pop. Do you know what an iron brew colour is?
A bit like Fanta?
A bit like Fanta, but a bit darker. Okay?
Okay. Dark orange.
And this one tells us the concentration of the sodium hydrogen carbonate. Okay? Which basically, luckily, as it's a 1-to-1 ratio, if we work out this, it tells us the number of moles of the sodium carbonate. So now, thinking about this, titration 1 tells us both sodium hydroxide and sodium carbonate, where titration 2 just tells us the sodium carbonate, really. So what we do, we work out the number of moles of 2. I'll write this up here. So number of moles of 2, which would just be the sodium carbonate. And if you minus that from, if you take your total moles of the sodium hydroxide, or solution number 1, and minus 2 from that, this value here will tell you your concentration or your number of moles of NaOH. So NaOH is basically number 1 minus number 2. And number 2 is just your concentration of sodium hydrogen carbonate. By the camera on me. Feel free to email me if you want to ask any questions about this. I think it's one of those things, you know, at the minute everything's up in the air. If there's one thing that we should do is this stuff comes up on practical exams in your A levels anyway. So it doesn't matter if we have an exam in year 12, it doesn't matter. You need to know this stuff. And what I'll do, I'll continue to post this kind of material. And hopefully you'll carry on doing it as well, please. So feel free to send me an email and I'll see you soon. Say bye, everyone.
Bye-bye.